So, there comes another researcher with unlimited questions and limited answers. And I hope I can give you a broad view on the issue, and I think it goes along the same lines as you have presented. Uh, First, I want to say there are a lot of promising examples in terms of circular economy on the company level, on the level of economies, on the level of sectors. And on the other hand, what we know is that things become bigger, things become more, and the main issue at the end of the day is what goes into the global economy and what goes out of the global economy. This is the bottom line when we want to become more sustainable. And so what we know as well is that looking back at the last 110 years, we always have used more, year by year, we used more, and we know we overstepped the safe operating space for humanity. So the question now is, what can circular economy really offer? What is the potential? What are the limitations? And before I go into that, I want to ask the question, how circular is the economy today? And at the system level. And I will use one definition. I think it's necessary to use a definition that is sound enough to base analytics on it. And I use one from the GEO5 report. And it's saying that if you have this global economy, there are two types of materials. The first ones are materials designed to circulate within the socio-economic system and reuse it and remanufacture it and recycle it. And there are other materials that are nutrients, biological material, that you extract from nature but give back to nature, and in a way that nature can digest it, can go through ecological cycles and be available again for extraction. Of course, there are certain conditions to that, because we are not in that state now. If we want to look what the circular economy is about and where we are. And one condition, of course, is that it's an effective reduction of virgin materials, so what we extract from nature. It's carbon neutral energy use, and when it comes to biomass, it's produced in a renewable way. Double safe. So, and that there are no net carbon emissions, so including the land use change that we use the sequestration of biomass. So this is the approach, and I'm afraid in my analysis I can't go into the details. Is it downcycling or really recycling? I have to say what I present now is the upper range in the scale of this kind of circularity. And so let's have a look into 2005. Sorry that it's 2005. We have done some estimates for other years, and it seems so there's not a big change. And we are very busy now in doing a time series from 1900 to 2010 and to better understand it. But now I present it for the year 2005. So when we look at the European Union, we extract materials 5.5 gigatons from nature, and we import 1.2 tons from other areas in the world. And this in minerals, biomass, fossils, ores, all these kind of different material categories. And together with what we recycle, that makes up 7.7 gigatons. So if we follow this flow, the first distinction we want to make is what of these extracted material is used for energy and what is used as material. And we can see that almost half of the flows are for energy. And energy, we consider biomass as energy as well, as soon as it's food or feed, yeah, and technical energy. And the other half is used as materials. And when we look what happens to these materials, most of it goes into stocks. And since stocks are growing, it's getting more and more. But as you said, stocks 30 years ago were small ones, so what comes out is not at the same level at what goes in, and this makes provides some limitations. So when we look now what coming out of the stocks and what are the short-lived products, then we see that we have about 2.4 gigatons of end-of-life waste. So this is the amount of waste we can talk about when we talk about recycling. And here we see now that still 5 gigatons are throughput and 1 gigaton is going back, is recycling. And now closing the loop in a way to the end. Where does it end? 3.1 gigatons are emissions waste and 1.9 gigatons are biomass, and this is potentially that kind of outflows that can be digested by nature. So let's compare this European picture now to the global scale. And Europe makes up about 12% of the global processed materials. And when we look at the EU 27, it has a slightly higher degree of circularity to the entire world. We can see the degree of circularity is a bit higher when you consider biomass plus this technical recycling. But in the rest of the world, the biomass share is higher than in Europe. The recycling in Europe, end-of-life recycling, is much higher than in the rest of the world. And the recycling of output is double than rest of the world. But as soon as we talk about what are the amounts per person, per capita, the rates, then we can see that the world has 10 gigatons input per capita, 10 tons input per person, and the European Union 16, so much more. And when we look what is the waste and emissions, despite the higher circularity, it's much higher in the EU. It's 10 tons per person what we put back to nature. So let's discuss some critical or crucial points in this flow model. We have the 7.7 gigatons of materials that go into the European Union, in the EU 27. So one important issue is that 46% is for energy use, is energetic use. So energetic use is not available for recycling because this material is just burned in combustions or in bodies. The other issue is from the material use, or from the entire flow, 43% are going into stocks. And these materials are not available for recycling now, maybe later on, depending on how they are produced. This means 89% of the materials we process in the European Union are not easily available for recycling or for circularity. If you look at the different point in the flows, we can see from the 7.7 gigatons that 38% are potentially available for circulating. These are biomass and the recycled materials, but still under the assumption that it's no downcycling, that the recycling does not need more energy than if it would be made from virgin material. And we see that 62% or 4.5 gigatons, for these there is no loop closing yet. And it's not possible to make proper loop closing for this. It's all the net addition to stocks and the energy. So these are important issues we have to tackle if we want really to push up the degree of circularity in our economy. And so the issues are reduce the share of fossil fuels, increase renewables, ensure sustainable production of biomass, increase end-of-life recycling, but consider as well that while we have very advanced technology in producing products, nanotechnology for example, When it comes to recycling, we have very old-fashioned, simple style of recycling, and the question is, how does this go together? Yeah, how can nanotechnology produced products be recycled in 5-10 years? That's an important issue that needs to keep up pace with the development in the production system. And then stock growth limits recycling, so it's very important to get to a level where stock does not grow anymore, because otherwise it's really limiting our potential for circularity. Yeah, and this means downscale European metabolism, societal metabolism. So coming to my conclusions, am I in time? We had some discussions about time when he saw my slides. So, closing the loops, I did some what-if analysis, and when we look at this issue of raw materials and DPO, so this is the emissions, this is important. How does this change? And we have in the year 2005 6.7 gigatons and 5 gigatons emissions and 13% circularity. What is if we increase the recycling rates by 20%? In some areas that is really pushing to the limits. In others, there is some space. We can see it increases the circularity to 15%, and it reduces the emissions to the environment a bit, and the raw material a bit as well. If we look at 50% decarbonization, so replacing fossil fuels, then we can see that it pushes the circularity up to 14%, not as much as the recycling, but reduces the emissions to the environment far more, and what we extract as well. So there is a huge potential when we go in that direction. If we say we cut the additions to stocks by 50%, so the net addition, the addition to stocks we have now, just 50% of it, yeah, we cut it, we can see this would increase the circularity to 16%, yeah, just because the flows become much lower, and it would have a long-term effect on the emissions. That the stocks are like a buffer as well, because everything that goes in takes some time to come out, and if we reduce it, we will not have the advantage immediately. So if we combine all these together, we could increase the circularity to 22%. This is not much, but it's very challenging, yeah. And there are many issues in there we don't understand really. I mean, if we really reduce the fossil fuels, it's not just the fossil fuels that is reduced. There are many more other things. The whole infrastructure has to change. We have to rebuild new infrastructure. So all these issues require some more careful modeling, yeah. And so this increasing loops is very challenging. It's a big policy challenge, and I think this needs a two-dimensional policy integration for tackling the resource nexus. And the one is from inputs to stocks to outputs, so across this line. And of course there are different departments and DGs responsible for different parts in there. And from energy to materials, and within the materials there are different material flows as well. So it's this two-dimensional integration where we are not very good at, I would say, yeah, and this is a real big challenge. Yeah, so on the one hand I have to say, even pushing up circularity doesn't solve all the problems. We have to stay within the limits concerning the absolute amounts of what we take out of nature and what we give back. And growing stocks are a real challenge that determines flows now and in future, because these stocks, they should be used in future as well, yeah. And shrinking flows and stabilizing stocks, yeah, is a major policy challenge. I'm happy that I'm a scientist. Okay.